My name is Ashraf Al Hassani, and I am going to present on my assignment using LMC and the CPU OS simulator. Right, so I have now opened my CPU, my LMC, which is Little Man Computer, where I have input my assembly code, my art program. So we are first one discussing the major activity one, where we have to input two values, add those two values, and then store the value in the memory cell 20. So as you can see here, we are loading. We have uh, we have inserted our assembly code in the simulator. Let me refresh my. Let me clear the memory so that we'll start everything from the beginning. All right. So this is the area where I have to input my assembly code, and then I'm done. I submitted. Then I click on step, and for the first step I'll have to input and I have to input the value of 5. So when I input the value of 5, the accumulator is updated to 5. Click on the next step, which is then to store the value of 5 in the memory address in mailbox 20. Let me all right. So when I click on again, I see that we'll have now the program counter to be added to 3, and then we'll have the code to be fetched from the memory address 2, which is 901, and I have to input another value which is -5. And when I click on -5, I see that our accumulator is updated to -0.05, and when I click on the next step, we'll have now -5 to be added. Yeah, so the instruction here is one, which is to add the value of stored in address 22 in the accumulator, and when you do that we get 0. And due to this no present yes due to this instruction BRZ, it says that if the value in the accumulator is 0, the PC should jump to 08, right? No, the PC should jump to should stop the program. Okay, so when I click on step again, we see that we have a fetch cycle here. Yes. So yeah, so branch if 0 to memory address 8, and there I see that our program will stop. Yes, program halted. We set load select all terminal. So as you can see here, we've successfully demonstrated the first part of the activity. Then we also have um, alright, so now we move to the second part of the activity one, which is our loop program, where you have to input a value. If the value is 0, we hold the program. Otherwise, we add it to the value in stored in 21. We store it in the memory at the 21, and then we go back to we go back to the first address, which is address 00. So I've input my program in the assembly code, and when I click on step, we can see here that we'll have to input here. So we start with 4 here. So when I click on 4, when I click on 4, I see here we have accumulator updated to 4. Then on step, since the value here is not equal to 0, we will now move to 121, which is to add the value of 4 to the address of 20, and then we have the answer to be 4. Then we'll store the value in address 21. As you can see that mailbox 21 has updated to 21 to 4, and then we go back to first our first instruction, which is to take another input. So we have to put another input here. So our next input will be 9. I'm going to click on 9, we have the accumulator updated to 9. Click on step. Since the value is not 0, we'll continue to move to the next address. We add it to the value stored in 21, which will give us 13. 4 plus 9, 13. Then we store the value back in 21, and then we'll move back to the first instruction, which is to take another input. We take 3 this time. Then we'll do the same process. We now have 13 plus 3 to be equal to 16. So here we added the input here to the value stored in memory address 21. Then when you click step, we go back to the first instruction. We take our next input to be 6. Since the input is not equal to 0, we can move on to the next instruction, and 6 is added to the value that was stored in 21, which is 16. So 16 plus 6, 22. So the accumulator is now 22, and then we've stored that value in 21, and then we'll go back to our first instruction. Then we'll input 0. When we input 0, our accumulator is updated to 0, and then this instruction here, BRZ, right, it checks the value of the input. If the value of the input is equal to 0, the code jumps straight to the instruction stored at 05, right, which is here 521. So when you click on step, you see here we have loaded into accumulator the content of RAM address 21. So it's been loaded there, and then we will receive an output here right at the top here of 22, and then our program will halt. Yes, so this is for the major activity A. So now I'm going to explain the Amdahl's law using the values are calculated in the second activity. Of activity 2 is the same thing as is the same process as the first loop, the first program that we run in activity 1. So I'll just explain, due to time, I'll just explain the Amdahl's law. And then so for the Amdahl's law, the Amdahl's law is used to calculate the overall speed up of a program when only a portion of it has been improved. So we mostly presume that when we increase when we increase the when you improve a portion of the computer, it's supposed the overall speed up should also increase accordingly. But due to Amdahl's law does not agree with that. So the overall speed up according to Amdahl is equal to 1 over 1 minus p, p plus p minus s, p divided by s. So where p is the proportion of the program that is being improved, and s is the speed up of that improved portion. So in my assignment, I have a total instruction count of 800 instructions and a CPI of 2.0, a clock rate of 2.5 gigahertz. So I used it to calculate the overall speed up, and I had 1.21. I had 1.21 during the calculation, and so even though the memory access instruction became 2 times faster, the overall program only became 1.21 times faster. And this is because the other 65% of instructions were not improved at all. And this demonstrates the core principle of Amdahl's law. That is, the unimproved portion of the program will contribute or will limit the maximum possible speed up of the program. So no matter how fast you make the memory instructions, you can never exceed a maximum speed up of 1 divided by 0.65, yes, which is 1.454 times. That's if you remove the portion of the unimproved portion of the program. Yes, so this is in a summary what the Amdahl's law is about. Thank you very much for listening. So as an insight to this, I would say that I was able to understand